Alright, in this video we're talking about lesson 1.7, to add and subtract decimals to solve problems involving those decimals. So when we first look at this, when we deal with decimals, we see them a lot with money and with purchasing things, and it's not easy to just add them up, getting a piece of paper out, so we have to estimate what the value of something would be, a total cost. So finding a decimal sum of 6 and 8/10ths, 4 and 65 hundredths, and 2 and 125 thousandths. Well, I'm going to estimate. So I'm going to say, well, 6 and 8/10ths, that's close to 7. And 4 and 65 hundredths, well, that's close to 5. And 2 and 125 thousandths, well, that's close to 2. So when I add 7 plus 5 plus 2, I get 14. Well, let's find how reasonable that answer is, how close of a true guess that was. So when I do that, I need to line up my decimals anytime I add or subtract. Doing so, I then need to fill in all of my placeholders that are empty with 0. So since 6 and 8/10ths only went to the tenths place, and the other two numbers go to the hundredths and thousandths, I'm going to fill in every single one of those that has a gap. With our 6 and 8/10ths, I put a 0 in at my hundredths, and I put a 0 in for my thousandths. Likewise, for this 4 and 65 hundredths, we put a 0 in at the thousandths place, so that when we add this up, we actually have something to add that place value with. So 5, 0, and 0, that's 5. 5 and 2 is 7. 8, 6, and 1 is 15. So I put my 5 down, and then I carry my 1. And 4, 6, and 2, can't forget that 1 I carried over, that's 13. So the sum, 13 and 575 thousandths, that'd be reasonable since it's close to 14. So I want you to now try this one on your own. Find what 84 hundredths plus 2 plus 3 and 32 hundredths is, but estimate first. So go ahead, take a second, estimate first, and then find the value of it. Alright, so now let's check to see how close of a estimation we have, and then find the actual answer. So I'm going to say that, well, 84 hundredths, that's going to, I'm going to round that to a whole. And then I have 2. And so that's obviously, I'm going to just leave that as 2. And 3 and 32 hundredths, well, that's going to round to be 3. So when I add 1, 2, and 3, I get 6. But to see, all right, how close of a reasonable answer did we have? Well, I'm going to add those up. So going back to what I initially had, I'm going to put a placeholder 0 in on my 2, simply so that it goes out to the hundredths place. 4, 0, and 2, I get 6. 8 and 3, we have 11, so I put my 1 down and I carry the other 1. And then I have 1, 2, and 3, and I get 6. Now, is my answer 616? No. I have to make sure that I bring that decimal point down into my answer. So when I compare my estimation at 6 compared to the true accurate answer of 6 and 16 hundredths, well, that's a reasonable estimation, but I mean, we were pretty close. So let's go ahead and look at a second example. And the second example is what we talk about with front end estimation. And this is, again, like we talk about with when we buy something to see, do I have enough money to purchase those items at a restaurant or at a concession stand. So when we look at it, and you do this a lot when you have whole numbers, your dollars, and then you have your decimal part, your change, the cents part of a cost. So when we do this, we're going to add the front end digits, and these are the dollar amounts. And remember, the scenario that we're in, a lemonade costs $1.79, sodas cost $1.29, and water costs $1.49. So we have to use front end estimation to estimate the total cost of buying one of each drink. So when we use front end estimation, I'm going to just look at my whole number, my dollar amount, and say, well, that's 3. Now the second step of this is that we add up all of the numbers to the right of the decimal, or our change, or the cents. And 79 cents and 29 cents, well, that's going to, if I were to ballpark what that's going to be, 7 is here, and then that 29, well, that's almost like 3, so I'm going to think of that as a single dollar. And then remember, we are only talking about the 49 cents part of this one, because we already used that 3 over here, or this 1 over in our first step to get that $3. So this is about 50 cents. So when I have my 3 already from our first step, I'm going to add in the change, or the cents part, and I have $1.50. So when I put my $3 and my $1.50, let's clean that up. When I add my $1.50 and my $3, I get a cost of $4.50 if I were to purchase one of each. Well, let's see how close we actually were. So if I have $1.79, let's fix that. If I have $1.79 plus $1.29 plus $1.49. When I add those together, well, 9, 9, and 9, well, that's 17. So 7 down, and carry my 1. 7, 2, 4, and I can't forget that 1. Well, that's 14. So I put my 4 down, carry my 1, and remember, I have to bring down my decimal point. I have them all lined up, and then I end up with 1, 2, 3, 4. So our accurate, what it's going to cost, is $4.47. Well, that's pretty reasonable, or our $4.50 was a pretty reasonable estimation, given that the actual cost would be $4.47. And then the same idea can be applied when we subtract, finding the difference. Remember, when it says find the difference, that means subtract. So first estimate, and then find 16 minus $8.79. We're not talking dollars, just subtracting numbers. So if I were to estimate, I would say, well, 16, that's 16. And then I'm going to subtract 8 and 79 hundredths. Well, if I were to kind of ballpark what that would be, rounding it, well, that's kind of close to 9. So 16 minus 9 is 7. Well, now I actually need to subtract. So doing so, I'm going to line up, I'm going to put my numbers in and line up my decimal. And remember, if 16, it doesn't have a decimal. So if it doesn't have a decimal, then we need to assume that it's at the end of it. Well, it's not assumed, but it's actually, our decimal point is at the end. So I'm going to put in my zeros and my tenths and my hundredths. And we now need to borrow, because I can't take 9 from 0. I can't borrow from my tenths place. So here it's showing us how we borrow. So I can't do anything from my 9 to 0, so I look to the next 0. This doesn't have any value, so it has to go to the 6. And the 6 it borrowed, or it became a 16 became 15, and now the 0 can become 10. So rename 16 as 15, and we have 10 tenths, because 10 tenths makes a whole, which is how that 15 becomes our initial 16 here. Well, that doesn't help our hundredths place, so I have to rename 10 tenths as 9 tenths, and then that extra tenth I just took away, well, that becomes 10 hundredths. So now I can subtract 10 minus 9, I have 1. 9 minus 7, I have 2. Keep my decimal points lined up. And then I have 15 minus 8, and I have 7. So check for reasonableness. This is, is your answer actually, within reason? The difference of 7 and 21 or 7 and 21 hundredths is reasonable, since it's close to 7 what our guess was. So since these are, pretty close, yeah, that's a pretty reasonable estimate at the beginning. And now this is where I want you guys to check to see your work. Go ahead and then hit pause and we'll check it afterwards. Alright, so for our quick check for the second one down here. Use front-end estimation to estimate the total cost of 1 small popcorn and 2 large popcorns. So 1 small popcorn and 2 large ones. Well, if I wanted to estimate front-end estimation, well, I could say that, well, the small popcorn is $3.98. So that's like saying I have 4, it's going to cost $4. And I'm going to add the cost of 2 large popcorns. And 2 large popcorns is, well, each one is $9.08. So I'm going to say that 2 of them, rounding $9.08 to, or $9.08 to $18, since there's 2 of them, estimate would be, it's going to cost around $22. So let's check and see how it's actually going to cost. Well, a small popcorn, $3.98, plus $9.08. Let's fix the 0 there. And another large popcorn, $9.08. So when I add these all together, 8 and 8 and 8, well, that's 24. 9 and our 2 that we carried over, that's going to be 11. And 3, 9, 9, and I can't forget that 1 that's up here, that's going to be 22. So our actual cost of what it's going to be is $22.14. And that's pretty reasonable estimation that we had at the beginning. We guessed that it was going to be about 22 with front end estimation. Well, it's going to be, yeah, that's good. Now we have to look at a graph at the right, and in your book you should see that we have these little angled sections with these lines that go across, and this is a shot, or it's a discus results. So how much greater is the women's record discus throw than the men's throw? And so when we compare the two, we have to look at a key. And our women's throw is the disc that has the shaded part with the white center, and that's this one right here. And then we have our men's throw, which is the white outline with the dark center, that's shorter. So let's check to see the difference. How much greater is the women's record throw than the men's throw? So we need to find the difference between the two. So I'd say, oh, I have 76 and it's 80 hundredths, or 86 and 8 tenths, and then I have to subtract my men's throw, and that's 74 and 8 hundredths. So when I subtract, I can't take 8 from 0, so I have to borrow from the 8 tenths, and that becomes 7 tenths. Now I have 10 hundredths, so 10 minus 8 is 2, 7 minus 0 is 7, 6 minus 4 is 2, and 7 minus 7 cancels that out. We end up with 0. So how much greater? Well, it's 2 and 72 hundredths meters. 2.72 meters greater is the women's throw. And you may be asking, well, is that true? And it actually very much is. I, went on double checking. Yeah, the women's world record back in 1988. It's a woman from Germany threw 252 feet, or 76 and 80 hundredths meter, and the men's record, a guy from Germany in 1986, threw 74 and 8 hundredths of a meter, or 243 feet and 53 hundredths of an inch, a little over half an inch. So that is a very accurate and true statistic right there. That's the end of 1.7. Let me know if you have any questions.